All right, this is section 12.1, Exponents. On to a whole different chapter. Chapter 10 was all about graphing. Chapter 12 is going more into some algebra. We're skipping chapter 11. It's not relevant to this course, so we don't have to worry about that. But chapter 12 is more algebra. Might be a little easier because it's not, I guess, as abstract as graphing may be. It's more step by step, and you can see the logical steps between everything. So 12.1, exponents, we're talking about how to evaluate them and what we can do with them in order to manipulate them. And these are crucial for what you're going to be doing in college algebra. So let's look at example 1 really quick from the book. It has a series of different expressions that it wants us to evaluate. We're going to evaluate all of these expressions. And this goes back to what we learned at the very beginning of class. So A says 2 to the third power. If you remember correctly, 2 to the third power, remember, is 2 times 2 times 2. You take the 2 and multiply it 3 times by itself. So that would be 2 times 2 is 4, 4 times 2 is 8. That would be your answer for that one. For B, 3 to the first power would be 3 times itself once. The answer is going to be 3. Again, a lot of these we haven't seen since the beginning of the semester, but I kind of warmed y'all up to them in the very beginning because I knew we would see them later on. If we have negative 4 to the second power, remember this is negative 4 times negative 4. That would then make positive 16. D, on the other hand, has the negative on the outside, and this is where I said it was tricky. You have to keep the negative on the outside, and it's 4 times 4. 4 times 4, according to PEMDAS, is negative 16. Apply the negative, that makes negative 16. So we get different answers depending on where the negative is. Negative's on the outside. Your answer is going to apply a negative after you multiply everything on the inside. This one, however, became positive. If we look at E, E says 1/2 to the fourth power. Now, even if it's a fraction, it still means the same thing. Much like this 2 to the third power meant 2 times itself 3 times, this would be 1/2 times itself 4 times. So all the top numbers, 1 times 1 times 1 times 1, make 1. And then all the bottom numbers, 2 times 2 times 2 times 2, make 16. So your answer would be 1 over 16. If we did F, which is 0.5 to the third power, that means 0.5 times 0.5 times 0.5. So it's still 1/2, but as a decimal. 0.5 times 0.5 times 0.5 will give you 0.125. G says 4 times 3 to the second. On this one, remember PEMDAS. According to PEMDAS, you have to do parentheses first, then exponents, and then multiplication. So PEMDAS, the throwback. We got no parentheses. We do have to do exponents first. So we have to do this before we multiply that 4 with that number. So 3 to the second power is going to be 9. And then 4 times 9 is going to be 36. So a lot of your orders of operations that we had from way back in the day are applying to this section. We're just kind of reviewing over everything and what they are. So let's look at example 2 really quick. Example 2 is very brief. It wants us to evaluate an expression with a given x value. So A gives us the expression 2x to the third, and it wants us to let x equal 5. So we did this in the very beginning of the semester again, where we substituted this value in for that x. So what we do is we do 2 parentheses 5 to the third power. You have to put this in parentheses. Go ahead and evaluate your exponents first, because according to PEMDAS, exponents come before multiplication. 5 to the third power is going to be 125. 2 times 125 would then make 250. That's all there is to this problem. For b, 9 over x to the second power, but it wants us to let x equal -3. So again, plug this -3 into here, but remember, put it in parentheses. I told you all how crucial that was way back in the day. I made -3 to the second power, so the -3 is in parentheses. Because if the negative was on the outside, it would affect our answer. -3 times -3 makes a +9. So 9 over 9, and that makes 1. That'd be our answer. So it wants us to simplify some of the expressions after we evaluate. But here's the new stuff. Let's look into example 3. One of our new things that we're learning is how to define exponents with variables and numbers. So remember that if we have 4 times 4, we can write that as 4 to the second power. If we have -6 times -6 times -6, we could write that as -6 to the third power. Same thing with variables. If we had x times x times x, that would make x to the third. If I had y times y, that'd be y to the second. As long as the same thing is multiplying on the bottom, you just represent that by having the exponent. So here, for this last example, we have 2 y's, so we would write it as y to the second power. Now remember, do not confuse the two between addition and multiplication. Remember, if I have x times x times x, that would make x to the third power. But if I have x plus x plus x, that makes 3x. It's easy to mix them up, but it's crucial to have it down so that it doesn't become too confusing. So x plus x equals 3x. Now, all of these x's right here have like a little 1 power. What happens is we're adding all of those exponents together to make this exponent right here. So if we have different exponents, say we have x to the second times x to the third, as long as these two bases are the same, we can go ahead and add the exponents. So what happens is we take x to the 2 plus 3 power, which makes x to the fifth. So we take these exponents, as long as these two bases right here are the same, we can add the exponents. So if I have y to the fourth power times y to the second power, you add the exponents in the top because these are the same. You're going to add the exponents if the bases are the same. So this would be y to the sixth power. If you add z to the third power times z to the ninth power, that would make z to the 12th power. Please do not multiply those two. You have to add them together. Remember, if I have x to the second times x to the third, that will make x to the fifth. But if I have x to the second to the third power, we went over this way in the beginning, that makes x to the sixth power. So I kind of briefly went over that at the very beginning of the semester, but we're going to go over it in depth here in a second. So if you're multiplying right there, if you're multiplying the same base, then we go ahead and add the exponents. So let's look at some examples from example 3. A says 4 second power times 4 to the fifth power. Rewrite that, that was kind of ugly. Instead of evaluating each one of these, we can just put them together because notice they both have a base power of 4. So if the bases are the same, you keep the base and add the exponents together. B says x to the fourth times x to the sixth. Add the exponents together, make x to the 10th. C says y to the third times y. Well, the y doesn't have an exponent. So if it doesn't have it written, we assume it's a number 1. We can assume that there's a number 1 up here. So that would then make y to the 4th power. D is y to the 3rd times y to the 2nd times y to the 7th. Add up all of these numbers together. 3 plus 2 is 5, plus 7 makes 12. That'd be y to the 12th power. E is negative 5 to the 7th power times negative 5 to the 8th power. These bases are the same, so we add the exponents. That would make negative 5 to the 15th power. F is a little different. This one says a squared times b squared. Notice these two do not have the same base whatsoever. So if they don't have the same base, we can't add them together, but we can just kind of put them together, just like this. This insinuates a squared times b squared. We just don't put the multiplication symbol in between. Much like when we write 2 times x, we write it as 2x. They mean the same thing. We don't need to put this multiplication symbol in between them. We can just put them next to each other. So these would just be next to each other because they don't have the same base. Now, let's look at example 4. That has a little bit more going on. We're going to use something called the product rule. We're going to simplify 2x to the 2nd power times negative 3x to the 5th power. So what we can do for this problem, I'm going to go ahead and write it down here so I have more room, is we're going to use that commutative property. Remember I told you the commutative property of multiplication back in the day? If you have 2 times 3 times 4, you could do 2 times 3 is 6 times 4, and then 6 times 4 would be 6, 12, 18, 24. Or if you switch them around, say you had 3 times 4 times 2, same exact numbers all multiplying together. We can do 3 times 4 first, that makes 12, times 2 makes 24. We get the same answer because the order that we're multiplying everything in doesn't matter. So for this problem right here, what we're going to do is we're going to multiply everything in a specific order to make it easier for us. So for instance, I have numbers and numbers, and then I have exponents and exponents. What we're going to do is multiply the numbers with the numbers first. 2 times negative 3 is going to make negative 6. Then we're going to go ahead and multiply the x squared and the x to the 5th with one another. Just like we learned, if we multiply them, we have to add the exponents together. So that would make x to the 7th power. So here's this, and here's that component. This would be your final answer. You're going to be doing this all the time later on. So 2 times negative 3 is negative 6. X squared times x to the 5th is x to the 7th power. That's all there is to it, to simplifying them. So let's take some other examples from example 5 and kind of practice this a little bit more. Example 5 says x squared y times x cubed y squared. This one we want to be strategic. The instructions for this are to simplify. Remember on the last problem we matched numbers with numbers and variables with variables. Here there's no numbers here, but we want to go ahead and match the variables with their like variables. So x to the squared times x to the 3rd and y times y to the 2nd. So if we do x squared times x to the 3rd, that would make x to the 5th. Y times y squared would make y to the 3rd. So the blue one and the green one. This would be your final answer. So you match up each variable, the correct ones that you want to multiply. Go ahead and erase all this. You want to match up whichever ones go together. So looking at B, negative A to the 7th power, b to the 4th, times 3ab to the 9th power. Again, everything is multiplying here, so we can use that commutative property. But notice we have like numbers right here. We have our a variables, and we have our b variables. So we're going to multiply the numbers with numbers. Remember, this negative sign is a -1. Then we'll do the a's with the a's and the b's with the b's. I'll put that in a green color. Now you don't have to draw all these like little brackets that you see me drawing right here. You don't have to draw any of those brackets. I don't need to see that. I'm just trying to help you visually see you match up the numbers with the numbers and the like variables with the like variables. So we do the negative times the 3, that would make -3. A to the 7th times a to the 1 power would make a to the 8th power. B to the 4th power times b to the 9th power makes b to the 13th power. And you're done. So a lot of this, it's not really hard to do this. It just takes practice to get the hang of it, and you'll be doing this intuitively once you get the hang of it. Right now, we're just learning a bunch of multiplication properties, and that's what's happening right now. So let's talk about the power rule. I just illustrated this earlier. Example 6. It wants us to simplify. This one says a, or the letter A is y to the 8th to the 2nd power. Notice the difference. These two exponents are next to each other. If they're next to each other like this, we want to think of multiplication. If you remember, whenever we have like a parentheses and there's numbers on both sides of the parentheses, this means to multiply. Kind of like if we have 2 times 3, we look at this as multiplication, so we would say 6. Or if we had 3 times -4, and we had both of them in parentheses, still means multiplication, that make -12. So I kind of view this as multiplication because they're next to each other. Whenever that happens, we just multiply the exponents. 8 times 2 is 16. But please remember, if I have something like y to the 8th times y to the 2nd, that's different. That's y to the 10th. That looks different than this. It kind of looks the same because they both have an 8 and a 2 and a y, but notice this one has that extra y. So if you're multiplying two bases, you add those exponents. If it's just one base to one exponent raised to another exponent, you multiply these two numbers in the top. That's the main difference. So b says 8 to the 4th to the 5th power. Again, these two are raised to each other, so we're going to go ahead and multiply them. That would make 8 to the 20th power. If we look at c, this one has a bracket, but they only put it because we have a -5 to the 3rd power to the 7th power. Again, the exponents are raised to each other, so this would be to the 21st power. -5 to the 21st power. And that's called the power rule. You're not going to be quizzed on vocabulary or anything like that. Just knowing how to look at them and know what to do with them. So that's another one of the rules, the power rule. And I'll summarize all the rules here at the very end. Example 7 illustrates yet another rule. Wants us to simplify. This one says st to the 4th power. All right, so this time we have two bases in the bottom, both raised to one exponent. So these two are both raised to that number right there. What that means is we have to distribute this 4 to the exponent to each one in the top, and it multiplies with each number that's right here. So what happens is 4 times 1 on the s makes s to the 4th power. 4 times 1 on the t would make t to the 4th power. It kind of looks like the distributive property whenever you have addition. That's how I thought about it when I was first learning this. If I have something like 2 times x plus 2, we distribute the 2 to both, so that makes 2x plus 4. Well, in this instance, we're distributing that exponent to both of the numbers on the inside. So b says 2a to the 3rd power. What we're going to do is we're going to distribute that 3 to the exponents that are up on top. So it has to go to this number that's up here and this number that goes up there. In this case, those are both 1s. So it'd be 1 times 3 would make 2 to the 3rd, and this would make a to the 3rd. I'm going to erase all these little marks because it looks a little confusing. You just distribute that 3 to both. Then you look at this, and you go ahead and evaluate. 2 to the 3rd is going to be 8, and a to the 3rd stays as a to the 3rd. Let's look at C. It says 1/3 mn to 3rd, all of it squared. Now this has a fraction in it. Might look a little scary, but we're going to go ahead and distribute it just like we did earlier. I'm going to take that exponent, distribute it to everything in the top. So this happens to become 1/3 to the 2nd power, m to the 2nd power, and n to the 6th power, because remember we have to multiply those two numbers. That's the property we just learned. 1/3 times 1/3 makes 1/9. And this becomes your answer. And the fraction one's a little tricky, but some of the problems will have fractions. A lot of them won't have them, but it's still the idea of distributing the exponent. Look at D. This one is -5 x squared y third z squared. Or I'm sorry, z all to the 2nd power. Again, everything in here is multiplying, so we can distribute that 2 to everything on the inside. We distribute that squared. So for the first number, it becomes -5 to the 2nd power. X becomes to the 4th power, y to the 6th power, z to the 2nd power. Multiply all these exponents by that number on the outside. So all the exponents are multiplied by 2. This one right here, -5 to the 2nd power, can be simplified. That becomes 25 x to the 4th, y to the 6th, z to the 2nd. A lot of rules going on here. So let's go ahead and learn another rule. This is example 8. It's called the quotient rule. So with the quotient rule, we're going to deal with exponents that are dividing. So a is m/n to the 7th power. Much like how we just distributed, if we had a, b to the, we'll say 3rd power, that becomes a to the 3rd, b to the 3rd. We're going to distribute this exponent to everything on the top and on the bottom. So it has to be distributed to everything. So this become m to the 7th over n to the 7th. We still multiply that top number with all of them. If we look at b, this one says x to the 3rd over 3y to the 5th to the 4th power. We're going to distribute that 4 to this number and everything on the bottom. So it has to go to the exponent here, and it has to go to the exponent here. We have to multiply that exponent with every other exponent on the inside. So this would become x to the 12th over 3 to the 4th, y to the 20th. We can simplify 3 to the 4th. 3 to the 4th is 3 times 3 times 3 times 3, which makes 81. So this would be 81y to the 20th. That's your answer for the quotient rule. A lot of different rules going on, so there's a lot to learn for this. But I would say after you get this stuff, a lot of the other stuff that we're going to be doing is going to be easier after you have this section really down. Let's look at example 9. Again, simplify. This is another part of the quotient rule. It says a x to the 5th over x to the 2nd. Here, something different happens. Remember, if you have like two different numbers that have the same base, you add the exponents, so that become x to the 5th. If you had y to the 3rd times y to the 4th, that becomes y to the 7th. So if your two bases are the same and they're dividing right here, see it's a division symbol instead of multiplying like we had over here. With multiplication, we add the exponents. So with division, we're actually going to subtract the exponents. This would actually always be the top minus the bottom number. So this would become x to the 5th minus 2, which is x to the 3rd. So b, 4 to the 7th over 4 to the 3rd. Again, since the bases are the same and we're dividing, we're going to subtract the top from the bottom. This will become 4 to the 4th power. And 4 to the 4th power simplifies to 256. Now, you might be asking, like, for that last problem, we didn't actually do that. Remember our last problem over here? M to the 7th over N to the 7th. Those two numbers right here, notice the bases are not the same. So this would be our final answer. We can't do anything with it. None of these bases right here, for those two, right here, those weren't the same. These weren't the same. So we couldn't actually do this division property. But here, all these problems, the bases are the same. So we can subtract the exponents from one another. So C is negative 3 to the 5th power over negative 3 to the 2nd power. Bases are the same, negative 3 and negative 3, so we subtract the exponents, which would make negative 3 to the 3rd power. Negative 3 times negative 3 times negative 3 makes negative 27. And that's your final answer for that. Let's look at D. D is S to the 2nd over T to the 3rd. These two do not have the same base, so those can't simplify. Your final answer would just be that number right there. We can't do anything for that one. Now let's go ahead and look at E. This is 2x to the 5th, y to the 2nd, over xy. Notice we have two sets of like variables. We have x's and y's. Remember, like on the multiplication one that we had a while back, if we had x squared y to the 3rd times x to the 4th y to the 2nd, we match them up. We do x's with x's, y's with y's. This one would become x to the 6th, y to the 6th, because you add up the exponents. Well, for this one, it's division, but we still want to do like numbers with like numbers. Right here, this number in the front is a 1. So we're going to go ahead and do 2 divided by 1 first. That would give us 2. x to the 5th divided by x to the 1 power would give us x to the 4th power. And then y to the 2nd divided by y to the 1st would give us a y. And I can erase all these little boxes so they're not too distracting. There we go. 2x to the 4th times y. So 2 divided by 1 makes 2. X to the 5th divided by x to the 1 makes x to the 4th. Y to the 2nd divided by y to the 1st power makes y. 5 minus 1 makes 4. 2 minus 1 makes 1. And that's your final answer. So again, that was another property of the quotient rule. Okay, so now we got one more rule to go over, which is the zero exponent rule. It's example 10. Again, simplify. So a has 3 to 0 power. The rule is anything, if I have anything, some kind of exponent or some kind of base to the 0 power, it's always going to equal 1 as long as a does not equal 0 as well. So essentially, any number you have on the bottom that is raised to this 0 power, the answer is always going to be 1. So if I look at b, this is 5x to the 3rd, y to the 2nd. This entire thing right here is raised to the 0 power. Well, if the whole thing's raised to 0 power, your answer is going to be 1. For C, it says negative 5 to 0 power. Well, it's raised to 0 power. It's equal to 1. Let's look at D. D is a little trickier. D says negative 5 to the 0 power. So remember, anything to the 0 power is 1. So this right there becomes 1. But don't forget to apply that negative on the outside. That would become negative 1. That's your PEMDAS rule. Here, this one, which is negative 5 to the 0 power, is 1. But on this one, we had to do 5 to the 0 power first, which makes 1, and then you apply the negative afterwards. E, this says 3 over 100, all to the 0 power, which is equal to 1. So that entire thing would be equal to 1 because all of this right here is raised to the 0 power, which makes 1. If I do F, 4x to the 0 power, notice it's not the entire thing that's raised to 0 power. Not all of it's in parentheses. Only this part right here is raised to 0 power. So x to the 0 power makes 1. The 4 stays on the outside. Only the x to the 0 power was raised to 0 power. 4 times 1 would then make 4. So the other example would have been if the entire thing, like this, was raised to 0 power, then that would be 1. But notice this one right here is not the same thing. So it's all about paying attention to the little details. 4x to the 0 power is 1. But if it's 4, then x to the 0 power, we have to apply the 1 first. Then it's 4. So the way the parentheses are affects everything. So that summarizes all of our different rules for exponents. Now it's a matter of how do we know which one to use. But let's go ahead and summarize all the ones that we've learned by practicing a bunch of different examples. It's like example 12 in the book. It just wants to simplify, and we have to look at every single rule we just learned. A says 4 to the 2nd minus 4 to the 0. So we can't subtract these two just yet. What we want to do is evaluate both of these. 4 to the second power makes 16, and as we just learned, 4 to the 0 power makes 1. 16 minus 1 is 15. For b, x to the 0 power to the third plus 2 to the 0 power times 5. We can use that property where we have the two exponents in the top like this and multiply them. So here we'll have to multiply these two numbers. That makes x to the 0 power. Here we'll have to multiply them. That would make 2 to the 0 power. And then anything to the 0 power makes 1. So x to the 0 power is 1 plus 2 to the 0 power is 1. Your whole answer becomes 2. So those are a little simpler. But let's look at one a bit more complex like c. 3y, oops, that's the entire fraction. 3y to the 7th divided by 6x to the 5th, all raised to the second power. This was a little tricky because we have to look at what we want to do first. Now, we could choose to evaluate some stuff on the inside, or we can distribute this exponent to every single thing on the inside. So that's what I'm just going to do to make it a little easier. We can distribute every single thing on the inside. So this would become 3 to the second power, y to the 14th power, over 6 to the second power, x to the 10th power. Have to multiply all of the exponents. Then we can go ahead and evaluate the 3 squared. 3 to the second power makes 9, y to the 14th, over 6 to the second power makes 36, x to the 10th. Then we're almost done. We can simplify this 9 divided by 36. 9 divided by 36, remember, think about it as like its separate little fraction, 9 over 36. The largest number that can divide into 9 and 36 happens to be 9. 9 goes into 9 one time. 9 goes into 36 4 times. So this would simplify to y to the 14th over 4x to the 10th. I didn't write the 1 here. You can write the 1 if you'd like to, but remember it means the same thing as without it. And then let's look at D. 2a to the third power, b to the fourth, all to the third power over negative 8a 9b to the second power. Whew, a lot of stuff. Remember way back in the very beginning when I started teaching this, I told you all to simplify the top and the bottom fractions individually before you decide to combine anything on the top and the bottom. So simplify the entire top first, then the bottom as much as you can, and then combine everything from the top and the bottom. So if I look at the top, I can distribute that 3, this to everything on the inside. This would be 2 to the third, a to the 9th, b to the 12th power. The bottom I can't even do anything. There's nothing I can evaluate, so I'm going to just rewrite it. Now keep simplifying top and bottom individually. The top I can simplify that 2 to the third. This would be 8a to the 9th, b to the 12th, over negative 8a to 9th, b to the second. Now that you can see that the top and the bottom are simplified individually, we can start combining them. Remember, put numbers with numbers, put variables with variables, and like variables with like variables. So the numbers with the numbers first. Oops, delete too many. Negative 8 divided by negative 8 makes negative 1. a to the ninth divided by a to the ninth. Remember, we subtract these exponents. 9 minus 9 makes 0. So make a to the 0 power. And then b to the 12th divided by b to the second. You subtract the exponents. 12 minus 2. That makes b to the 10th power. We learned anything to the 0 power makes 1. So negative 1 times 1 times b to the 10th. Negative 1 times 1 makes negative 1, and that could just simplify to negative b to the 10th. That would be your answer. Now, there's one step we could have skipped. Whenever we're dividing this stuff, erase this. Notice right here, for this and this, they're the exact same thing. A to the ninth divided by a to the ninth. When we divided them, made a to the 0, which then made 1. Well, anytime you see the same exact answer right there, I'm going to go ahead and copy this over. Let's copy, and then we'll paste it. So we have another one. So we can show you a different way. If we have these two as the same, what you can do is just cancel them out. A to the ninth divided by a to the ninth. Remember, we would say like 2 divided by 2 makes 1. If I have like 10 divided by 10, that makes 1. It's the same number divided by the same number. It always makes 1. If I had x divided by x, it should equal 1. Well, a to the ninth divided by a to the ninth is going to make 1. So what we'll sometimes do is just cross them out like that. And then we can go ahead and simplify. 8 divided by negative 8 still makes negative 1. This still makes b to the 10th. So this would make negative b to the 10th. It's really just a little shortcut. So all in all, there were a ton of different things that we just learned in terms of all of our different properties. We had like the quotient rule, the product rule, a lot of stuff that we went over, deciding on which one that we need to use for each one. And it takes a lot of practice to get this down, but once you get it down, it's going to make the rest of the math easier for you. So go ahead and try out the homework. Remember, you can try out some of the boot camp to practice to get the hang of this. And if you start doing the boot camp while doing the homework, just do the boot camp problems up to 12.1 and then stop and then do the next one if you want extra practice. After that, go ahead and move on to 12.2.